In naming ionic and molecular compounds, this is going to be a helpful review for the final because it deals with Chapter 2 and Chapter 3 concepts. So the periodic table is a Chapter 2 concept, and it's a useful review to look over the different types of elements on the periodic table and how the periodic table is organized. Then from pages 2 to 4, we're reviewing, exploring, naming molecular compounds, actually binary molecular compounds that do not have hydrogen in them. And if you recall, we use these Greek prefixes, and this reviews how to name these and give some examples, and it's generally pretty useful. Then when we get to page 5 of the Explore section, we look at naming ionic compounds. And it takes a lot of time to review this, it being HOL. And for us, we're just going to name ionic compounds by putting the cation name and then the anion name. So we have to know the names of the cation, we have to know the names of the anions. If most cations are based on metals, and if a cation has a constant charge, like the group 1A, the group 2A, and aluminum, zinc, and silver, then the cation name is exactly the same as the element. So sodium and lithium are group 1A, their charges are always the same, so the name of the cation is the same as the element. If our anion is based on a non-metal, then it retains the element name and ends in "ide." So the name of this is sodium chloride, the name of this is lithium nitride. We do not say trilithium nitride or sodium monochloride. In ionic compounds, we know what the charges are, and we use those charges to determine the formulas. So one of the things that HOL does is it talks about something known as oxidation state, which is really beyond the scope of our course. So you may have to go back to Chapter 3 really and to review how to name these. Now, it does go over the cations that have a fixed charge, group 1A, group 2A, aluminum, zinc, and silver. And then again, it refers to these charges as oxidation states, which is not incorrect, but we're really not going to look at oxidation states in this course yet. Okay, then it goes on how we write formulas for ionic compounds, and the whole idea is that we need to cancel out the charges. So when we look at an ionic compound, the formula is based on the charges and what ratio of cation to anion do we need to get those charges to cancel out. Now, if a metal has a variable charge, then the charge is expressed as a Roman numeral. So gold 3 has a +3 charge. Gold is variable, and so its charge has to be expressed as a Roman numeral. And then here on page 8 of your Explore are a list of the polyatomic ions. Many of these are similar to those that you found in your textbook, but it might be useful just to go here because these are the ones that will be used for your lab. And again, it talks about these oxidation states in the polyatomic ions. Not that useful for us. Okay. All right, and then it goes on how to name compounds with polyatomic ions, and basically, again, it's just the cation name and the anion name, and when we determine the formulas, we are trying to cancel out the charges. One mistake that people often make is for a polyatomic ion, they think that the subscript is the charge. That's not correct. For example, nitrate, NO3, that subscript 3 means there are 3 oxygens, but the charge is just -1. So when you're determining the formula, we definitely need that subscript as part of the formula, but we're looking at the charge to determine what the ratio of cation to anion is going to be. Okay, now they also talk about naming acids. If something begins with a hydrogen, then it is an acid unless it's water for our purposes. And we didn't really go over that yet. We will, but we haven't yet. And you can just use this table to name the acids in this lab. Another review is the diatomic elements. These are the 7 elements that exist as diatomic molecules. Important to know. And then here's a little flow chart to help you as you're naming these compounds. Does the compound contain a metal or the NH4 cation? And if it does, it's an ionic compound. If it doesn't, it's molecular or it's an acid. Does the metal have a fixed charge? Then we just name the metal and name the anion. And if it doesn't, then we have to figure out what the charge of that cation is, and that charge is expressed as a Roman numeral. And then the anion comes second, and some tips on naming that anion is here. So hopefully this will be a good review of Chapter 2 and 3 concepts.